This is Algebra 2, Lesson 51A. There will be a couple videos here, and the name of this is Imaginary Numbers, Product of Square Roots Theorem, Euler's Notation, and Complex Numbers. Okay, so we're going to start out with imaginary numbers, and you're like, oh my gosh, are you kidding? It's hard enough using letters and real numbers, and now you're talking about imaginary numbers that really don't exist. Well, you're going to find out imaginary numbers are not hard. In fact, most students kind of like them because they're pretty easy. Alright, so if we have the square root of 4, we're asking for what two numbers multiplied together give me 4. And you're going to say 2. 2 squared equals 4. But what about negative 2? What happens if we square that? A negative times a negative is a positive, and 2 times 2 is 4, so we get that. So the answer to the square root of 4 is actually plus or minus 2, either positive 2 or negative 2. What we normally do is we just say it's 2, because that is called the principal root. And that's usually in math what we use is the principal root. But we can get negative 2. We just choose sometimes not to. Alright, so there are times that when we have the square root of 3 times the square root of 3, we get the square root of 9, which is 3. We could just write this as square root of 3 squared. And this root right here, because this is squared, the root and the exponent cancel each other out. Because what happens is the root, the index in here, is a 2, meaning we're going to take the square root of 3. We're going to find out what number times itself gives us 3. And in this case, it's going to be like this huge decimal. But anyway, so this 2 and this 2 cancel each other out, which leaves us with just 3. So we don't have to write this step and then this one. We can just write 3. Just take off the exponent, take off the root symbol, and you're done. Alright, so let's look at imaginary numbers. Imaginary numbers are numbers that kind of exist when you are trying to find the square root of a negative number. So I'm trying to find two numbers multiplied together that give me negative 4. Well, what is 2 times 2? That's positive 4. What's negative 2 times negative 2? That's also positive 4. So those are the only options we have to try to get a negative 4, and neither one of them give us a negative. They both give us a positive. So there's not a number that we can represent on the number line that gives me negative 4. So that's an imaginary number. And we will come back to that in a minute when we start talking about Euler's notation. Now, you know, every year we give an Euler award to a math student, and this is where it comes from. He invented the imaginary number cool thing. So, anyway, just so you know, you have an imaginary friend there. All right, let's look at example 51.1. We have the square root of 3 times the square root of 2. Okay, so the product of square roots theorem says if we have that, we leave the square root there and we just multiply the two numbers together. Okay? Not too bad. What if we have the square root of 3 times the square root of negative 2? We do the same thing. We multiply the numbers together and get negative 6. Okay? Now if we have the square root of negative 3 times the square root of negative 2, we get something totally different. We get square root, or negative square root of 6. Alright, and this is where Euler's notation comes in and the whole imaginary number thing comes in. Because this times this, you would think, would give you a positive. But it doesn't, because this gives me my positive square root of 6. This, two different numbers, cannot give you the same thing, and it actually gives you this. So I'm going to explain how that works when you have a negative sign under the radical. Okay, so we've got this guy named Euler, and he is teaching us, or he made up, that when we have a negative square root, and let's just do it real basic, square root of -1, that equals the letter I. Okay, and back in the olden days when they used these pen quills and they used to have to dip their pen in ink and draw, they tried to make things with as few strokes as possible. So instead of writing the square root of -1, he just said, let's just use I, because I can use I without using as much ink. So that's where that whole I came from, and all that does is represents the square root of -1. So if I have the square root of -6, that equals the square root of -1 times 6, right? And we're going to take that -1 and we're going to split these up into the square root of -1 times the square root of 6. And if we just said that I equals the square root of -1, instead we're going to write it as I square root of 6. Okay, so that's what that means when I write an imaginary number. I just put the letter I for the square root of -1. Or another way students look at it is, oh, there's a negative sign. That means I'm going to put an I outside and leave everything else alone. So we're just going to take the negative, make it into an I when we pull it out, and be good. Okay, so let's look at some examples using Euler's notation. And again, it's not really that hard. I don't think you have any trouble with it at all. Let's look at the square root of -13. Okay, that equals the negative, pull it out, and the 13 stays in there. Okay. If we look at the square root of -4, the I comes out, we have the square root of 4, which is 2. So we're going to take the square root of 4 and put it as 2, and then put the I on there. I have the square root of 3 times the square root of -2. I've got the square root of 3, and this one here, I'm going to take out an I, and I've got the square root of 2. And now I can multiply what's in the radical sign. Remember, you can multiply anything. And then I've got my I. Usually put your I at the end. Okay. I've got it up here in the front. It's not really a bad thing, but the better way is to put it under, or at the end. Okay, so that's pretty much it as far as imaginary numbers with this particular lesson. We'll do quite a bit more with it later, but we're going to deal with complex numbers. Complex numbers include imaginary numbers. So if you have all the numbers in the whole history of the universe, you have real numbers, and then you have complex numbers. Complex numbers include our imaginary numbers here. Alright, so they're numbers that kind of don't really exist, and complex numbers are written with a real part and an imaginary part. So that is a complex number. The number 4 can be written as 4 plus 0i. There's no imaginary part to it, so 0 times I is 0, so we just write it as 4. Let's say we just have the imaginary part. We might write the real part as that and then write like that. So this doesn't really exist, it's just 4i, but we're showing in the correct format the real number and then the imaginary part. You might see it written like this, a plus bi. In fact, you will later when you get into college algebra. This is the real number part, this is the imaginary part. Okay, so what do we do if we're going to try to add these imaginary numbers together? Let's say that we have 4 plus 6i plus 3i minus 2. So to add these is pretty simple. You just add the real numbers. 4 minus 2 is 2. And then you add the imaginary numbers. 6 plus 3 is 9. And you're done. Okay? And you leave it in that format. Real number here, imaginary number there, and you're good. Alright, so let's keep going. Example 51.4. We have 4 minus 3i plus 6 minus 4i minus 2 minus 5i. Alright, so remember parentheses. You can take off any parentheses as long as there's a plus sign in front of it. There's a minus sign here, so in order to take off the parentheses, we have to change the sign of everything inside that parenthesis to take off. Okay, now I combine my real numbers. There's a 4 plus 6 minus 2. 4 plus 6 is 10, minus 2 is 8. Then I do a negative 3i, negative 4i, positive 5i. So negative 3i minus 4i is negative 7i, plus 5 is negative 2i. And you're done. Alright, so next video, well, no, let's just go ahead. I think we can finish it on this video. Let's look at example 51.5. And one of the things that we have here is 2i minus 3i plus 2i minus 4 minus the square root of negative 4. Alright, so they're wanting us to simplify there. Well, let's go ahead and do this. Before we get any further, we talked about the square root of negative 1 equals I. Another thing that's important to realize is what happens if we square that. Okay, let me go ahead and write it as a separate thing. Negative 1, oops, squared. That means that the exponent and the radical sign go off, and that gives us negative 1. Okay, so if we took whatever this was and square it, or if we took I and squared it, because I squared equals that, right? Or that, because if I equals this, then if we square that, it's the same as squaring this here, which is right there. Okay, so all that to say, if I equals the square root of negative 1, then I squared equals negative 1. And I'm going to give you another one. I cubed. I cubed is going to be, I don't do it the way the book does, but I cubed is going to be the square root of negative 1 times the square root of negative 1 times the square root of negative 1. This is the square root of negative 1 times the square root of negative 1 is negative 1 times the square root of negative 1, which is this here. And the square root of negative 1 is I. So I cubed is actually negative I. Okay, let's wait for that to sink in a little bit. You don't have to memorize how to do that. All you have to do is know that the square root of I cubed is negative I. And the last one we're going to deal with is I to the fourth is equal to 1. You are going to need to write that in the front cover of your book if it's not already there, or in your notes, because that is going to be very, very, very handy later on. I'm going to have to go ahead and go with another video and running out of time.